Hi everyone, welcome back. This week in Level E, we'll be going over lessons 101 to 104. You will need worksheets 73 through 76, the warm-up practice sheet 10, one set of tangrams, the goniometer, the 4-in-1 ruler, geoboards, scissors, the large shaded circle from lesson 98, we just need one of them, a protractor if available, drawing board and T-square, the math card games book, the basic number cards, and the multiplication cards. In lesson 101, we will review a few terms and discover that triangles with equal angles have equal sides. The warm-up questions are oral this time. Then we'll discuss the terms isosceles and equilateral. Remember that isosceles triangles have 2 equal sides, but equilateral triangles have 3 equal sides. So while not all isosceles triangles are equilateral, all equilateral triangles are isosceles. Let's look at how we can create various triangles with the tangram pieces.
Okay, so the instructions say to put 2 small tangram triangles together and then to have the child slowly pull them apart. See how we're making a triangle on the paper here. Slowly pull them apart until the short side of the medium triangle can form the base of the new triangle. So there we go. And what kind of triangle have we created? We have created an equilateral triangle. All 3 sides are equal. Another way we could do this, if we didn't want to use the medium triangle, is we could take a small triangle from the other set because they're the same length. And you can go ahead, if your child isn't sure, go ahead and just line that triangle up, or any of the green ones, small green ones, up to the short side of the medium triangle, and you'll see that it's the same size. So then, leaving those triangles in place, we're going to put the big triangle down. We still have this equilateral triangle here in the middle, but now we're going to spread the small triangles out until we have a straight line across here at the top. Now we have formed an isosceles right triangle. Your child can test that with the goniometer to see if this is really 90 degrees here. Now we're going to keep going, spreading out the little triangles a little bit more. We can actually go all the way until they practically touch the corner of the big one, but it could be anywhere here or here. It doesn't really matter, as long as we can see that this angle right here is now an obtuse angle. It's more than 90 degrees. Okay, before starting the worksheet, I want you to point out to your child that a shape is the same shape regardless of whether it's flipped around or turned or whatnot. So this triangle is the same as this triangle. The reason why I'm warning you about that is just because when the children are asked to make their own triangle, oftentimes they just think of the reflection of that triangle rather than actually creating a new triangle with new angles or new side lengths. Okay, let's take a look at the worksheet. This is worksheet 73. And I just want to point out the bottom problems down here. So these are representations of geoboards, and the child is supposed to draw different triangles on each of these geoboards. Now, this might work great for some kids. Some will enjoy actually using the geoboard, in which case you want to separate out a 3x3 square here, and then have the child create the triangle within this boundary.
Okay, so once your child is finished with that worksheet, go ahead and ask the in conclusion questions and play any game of your choice. In lesson 102, we will classify triangles by sides and angles and learn the terms scalene, acute, and we'll review the term obtuse. On practice sheet 10, have your child complete the multivide, and then I would point out that on worksheet 74, there's not a direct correlation between the two charts. Let's take a look at that.
Okay, so looking at this chart up here, while an equilateral triangle does have acute angles, not all triangles with acute angles are equilateral. Likewise, a right triangle, here's the right triangle category, is an isosceles triangle, but not all isosceles triangles are right-angled triangles.
Okay, so after discussing the definitions for both the sides and the angles, ask the name my triangle questions, and then have your child complete the worksheet. Ask the in conclusion questions, and then play any game of your choice. In lesson 103, we will classify polygons as regular or irregular. Go ahead and ask the warm-up questions and review the different names for triangles. Then review what polygons are. Take a look at worksheet 75. Have your child look at the polygon chart. Before discussing the definition of regular and irregular, you may want your child to try to tell you the definition based on the pictures. Follow the classifying polygon discussion and then have your child complete the worksheet. Ask the in conclusion questions and play quotient race game, which is D4 in the Math Card Games book. For lesson 104, there is a correction. If your book was printed before May 18th of 2017, please follow the link in the description to find the correction. In today's lesson, we will classify angles and make our own protractor. The oral warm-ups are reviewing the types of triangles. The triangles on worksheet 76 are for lesson 105, so have your child cut those out and save them. Just set them aside. The circle that's on that worksheet will be needed today, so that should be cut out and combined with the dark shaded circle from lesson 98. Those are the ones that went with the fraction and percent circles. Let's take a look at the questions that are related to this.
Okay, so here's the circle that you just cut out for this lesson. And we're going to combine it with the shaded circle from lesson 98. Okay, and then you can just ask your child questions. So for example, tell your child to find 30 degrees. So they'll just rotate the shaded circle over to 30. There, this opening is 30 degrees. Here's 60 degrees. What are those two angles called? They are acute angles. Now the book says that it's easy to remember that because the capital A has an acute angle. My kids liked to think of, oh, look at the acute angle. It's a small angle. Okay, then you could find 180 degrees. What does that look like? It looks like a straight line. Here's 90 degrees, for example. 90 degrees would be a right angle. And then they could go over to say 130. What would be the name of that angle? That is an obtuse angle.
Next, your child is going to make a protractor. If you happen to have one from the store to show as an example, that will be very helpful. Otherwise, I would just show the picture on page 201. Protractors measure angles just like goniometers do. The purpose in making your own is to understand how the protractor works. The commercial ones can be kind of confusing because they can measure from both sides. So there's two sets of numbers, and that can confuse children a lot. Your child's homemade protractor will not be perfect, but the process is more important than the product in this case. And even so, we want to have your child try his or her best. So erasing and making it as good as you can get it makes the final product more usable for the next lesson. If this is truly a struggle for your child, maybe they have some dexterity issues, I would just let them use the store-bought protractor, but go ahead and point out that we're just dealing with the numbers starting with the 0 on the right and going over to the 180. Or you could make it yourself, make the protractor yourself, and have your child watch you do it. That might be even a more helpful thing than using the store-bought protractor. So go ahead and finish up this lesson with the in conclusion questions, and then once again, play any game of your choice. That's all for this week, and we'll see you next time. Thanks so much. Bye-bye.